Now, in the last video, we looked at the concept of Go routines and how we could spin up Go routines using anonymous functions and named functions. Now, more often than not, whenever you're developing concurrent applications in Go, you'll need some form of mechanism that allows for communication between your different Go routines. And this is where channels comes into play. Now, channels are effectively pipes that link between your different Go routines and allow you to send and receive messages from other Go routines to each other. Okay, so let's start off with an example. And let's say I wanted to calculate some values or a value within my Go routine and pass that value back up to the main thread running within the main function. Now, what I could do is I could create a values channel. I could use the make keyword. I could specify it's a channel and the type, so it's an integer. And let's update this function, so it's going to be called calculate value. And I now want to take in the channel that we've just created. So let's say values channel of type int. So this is the expectation. We want to pass in the channel of type int. Let's take this values channel here and pass it in. And then let's calculate a random value. So let's say value is equal to rand.intn up to 10 fmt fprint f, and let's do value calculated calculated percentage %d, pass in the value, and let's add a new line character. And then let's pass this value that we've calculated back up to the values channel. So let's do values. And then we have to use this less than minus sign syntax to pass the value back to this values channel. Let's save that. It should import the math rand package. And let's now update the main function. So let's say we're going to assign a value to the first received value to the channel. And we can use this syntax here. And then we can say fmt println value, like so. Now, the act of receiving something to our channel, in this case to the values channel that we've created, is a blocking call. And we effectively block until something is received, and then we assign that to the value variable that we've got defined here, and then we print this out. Now, overall, this is a cleaner approach than using the time.sleep method that we used in the previous video, as it ensures that the Go routine that you have triggered finishes its execution. So if we only send after we've finished the execution, then we can guarantee that our Go routines aren't terminated early. Cool, so let's open up the terminal and do go run main.go. And as you can see, our calculate value Go routine that we have here has successfully calculated the value using the rand package. And then it's passed this value back up to the values channel that we've passed in here. We've then blocked until we've received this value in the main thread and assigned it to the value variable, and then we've printed out this value variable here. Cool, so that's all we're going to cover in this video. Just to recap, in this video, we've looked at how we can instantiate a new channel within Go using the make keyword. We can specify the channel and the type that we want to pass in. So we could change this to string, int64, or whatever you want to pass in. We've then looked at how we can then pass this new channel to our Go routines. And then we've looked at how we can send and receive values to and from this channel. Now, in the next video, we're going to be taking a look at buffered and unbuffered channels and how they differ from each other and how we can use them in different situations. In the last video of this course, we covered the topic of channels within Go. Now, we looked at how we could instantiate a channel using the make keyword and the channel and then the type for the channel. And then we looked at how we could both send values to the channel and receive values from the channel. Now, this channel that we created is known as an unbuffered channel. In this video, we're going to look at how we can create this or modify this in order to make it a buffered channel. Now, what does this mean? Well, a buffer channel allows us to block when a channel is full. So we can basically set a capacity for a channel. So say we only wanted to have, say, 10 elements within our channel at one time. We could pass an additional argument to the make command, and this value would represent the capacity that we want our channel to have. Now let's, for example, change the calculate value function to calculate values. And let's do the following. So let's do for I is equal to 0, I is less than 10, I plus plus. Let's wrap all of this. So this is effectively going to send a random value to the channel that we passed in 10 times. So it's going to loop through this 10 times and send this random value 10 times. Okay, so the next thing we want to do is to update our main function. And let's do for I is equal to 0, I is less than or equal to 10, I plus plus. And let's move this into the for loop. So this is going to receive a value from the values channel 10 times, which is the same. Let's make this the same here as well. So it's going to listen 10 times and read the value 10 times. So go run main.go. As you can see, it's instantaneously calculated the value and sent the value to the values channel 10 times within this go routine. And we've also read the value 10 times within the main function. Now let's add a little bit of a delay. So let's change the capacity as well. So let's say capacity 2. And let's do the following. So time dot sleep 1 times time dot second. Save that, should import the time package. And let's run this again. So go run main.go. As you can see, we're now seeing a delay as the buffer is getting filled faster than the reads are happening on this channel. So if we scroll up to the top of the output, you can see that we've calculated 3 values and then we've got a bit of a pause. So we're reading these values one at a time and appending a new value one at a time. So this is effectively the block on the send, as the capacity of the buffer is currently at maximum. So you cannot send a new value to the buffer when it's at capacity. And we can see that here. Every second we see a new value is calculated and a new value is consumed from this buffer channel. Now, why is this useful, you might ask? Well, let's think of the channel as maybe like a task queue, and we want to limit the number of tasks being added to this queue and then consumed by another part of the application. Well, this technique or this approach effectively allows us to minimize the amount of channels or the amount of tasks that we add to this channel and ensure that it doesn't grow to an unmanageable size. Now, this approach can actually help you prevent an out of memory issue. If you're using an unbuffered channel, then you might see that your producers, so the functions like the calculate values function here, might produce faster than you're able to consume, and you might eventually get to the stage where your Go application uses all the available memory on the machine or the server it's running on, and then it crashes, which is no good to anybody. Cool. So in this video, we've covered the topic of buffered channels and how they differ from the unbuffered channels that we created in the previous video. We've covered some of the pitfalls and the caveats of using unbuffered channels and why you should generally try and use buffered channels where possible within your Go applications.